Okay, today will be the third and final day of 7.2, and we're going to talk about the rational exponents that have numbers and variables inside of the radicals. So we look at number 1, and we've got the cube root of this whole quantity and the cube root of that whole quantity, and we see that they are sharing the same root. So we're going to combine them together underneath one radical. 10 times 2, since we're multiplying those two pieces, gives us 20. X to the fifth times x to the third. When we are multiplying like bases, we add the exponent, so 5 plus 3 gives us x to the eighth. We are taking the cube root of this quantity, so we break down 20, 4 and 5, 2 and 2. We need 3. We don't have any groups of 3 here, so no number can go the outside. I have x to the eighth. If I only need groups of 3, that means I can bring 2 groups of x's out, because 2 times 3 will give us 6. And then left over on the inside is that 20 that could not be broken down into any groups of 3. We took out 6 of the x's, which means we have 2 left. As we are putting everything together, I want to make sure that you are careful when you are writing your final answer. We do have the x squared, and then we have the cube root. Sometimes people forget to write what root you are writing down because you have that squared and there's so many superscripts that you get confused. Always double check in your final answer that you remember to write down what root you are taking. If you forget that 3, it does change the whole meaning of the problem. Alright, moving on to number 2, I think that the easiest way to do this is to change it from radical form into exponential form, and we've got multiple exponents here. 27x to the fifth is in the inside, 7th root all raised to the 4th power. There's a couple different ways that you can write this. I would take the entire base of 27x to the fifth, and that is being raised to the 4/7 power. You also could have done to the 5/7, which is okay. You would just have to be careful that you're not raising the 27 to the 5th power, because we see that that 5 is only going with the x. So when we go ahead and distribute this, that's 27 to the 4/7 and x to the 27. I'm going to rewrite 27 as 3 cubed raised to the 4/7. X to the 27, we'll deal with that in a little bit. And that becomes 3 to the 12/7. Now at this point, you should see that both of them are taking the 7th root, which is from the beginning. So we have the 7th root of 3 to the 12th power and x to the 20th power. We have 7, we need 12. That means I can bring a group of 3's to the outside. For the x's, I can bring 2 groups of 2 groups of x's. If I took 7 3's away, that means I have 5 3's left. If I took 2 groups of 7, that means I took 14, which means I have 6 x's left. Then we want to evaluate. So this is going to become 3x squared. The 7th root of 3 to the 5th power is 243, and then the x to the 6th power. So don't forget that numbers and variables follow the same principle, but they've got a little bit different going on. For number 3, we've got the 4th root. Well, we have the 4th root of 1 on top, so we know that that's just going to be 1. On the bottom, we've got the 4th root of 8 can be rewritten as 2 cubed and x cubed. We need groups of 4. We have 3 2's, we've got 3 x's, which means I just need one more 2 and one more x to rationalize that denominator so that I have the groups of 4. So on top, I've got the 4th root of 2 to the x. On the bottom, we've got that group of 2, so that goes to the outside. We've got that group of x's, so that goes to the outside. So we've got the 4th root of 2x all over 2x. Number 4, we have the cube root of 81x to the 5th, y to the 6th, z to the 7th. 81 we know is 9 and 9, 3 and 3. So this is really 3 to the 4th power. We need 3 of them to go to the outside, so I can bring one group of 3 out. Sometimes I find it easier to write the 2 pieces out, so if I'm taking 3, I've got 1 left, that way I don't forget about it. X to the 5th, I can bring one group of 3 out. 5 minus 3 leaves us with 2 x's. Y to the 6th, I can bring 2 groups out, none left over. Z to the 7th, I can bring 2 groups out as well. But that's 6, which means I've got 1 z left over. And that would be my final answer. Go ahead and press pause, and I want you to try number 5 on your own. It's very similar to what we just did in number 4. Okay, so first I started with breaking down 243. That's really 3 to the 5th. We need groups of 4. We already had 4x squared out there, so we don't forget about that. That stays out there. Whatever we also bring out is going to get multiplied. We need groups of 4. We had 5, so we could bring 1 3 out. We still had 1 3 left over. X to the 13th, I could create 3 groups of 4. 3 times 4 is 12 with 1 x left over. If I have 16 y's, I can create 4 groups of 4 with none left over, so that gives us y to the 4th on the outside. Then we multiply the piece that was already there and the piece that we brought out. 4 times 3 coefficients are just multiplying. That gives us 12. When we multiply the same variables, we add the exponents. 2 plus 3 gives us 5, and then just the y to the 4th power. For number 6, we have lots going on here. We look for something that they all share, and I see that they are all bringing or have the 3rd root. Besides that 2 is going to stay on the outside, and I'm going to put that 2 over 1 so I don't forget that that's on the top of my fraction. And I multiply that by the cube root of x to the 3rd 2x squared times 32x to the 7th. Again, 2 over 1. We're having the cube root of all of this. We have x cubed on top. 2 times 32 is 64 on the bottom. X squared times x to the 7th is x to the 9th because we add those exponents. Then we want to simplify here. Cube root of who wins? The bottom wins, so we've got 1. 64 can be rewritten as 2 to the 6th power, and that's x to the 6th power. We have the cube root, so we need groups of 3. Remember, the cube root, any root of 1 is just 1. So on the top, that becomes, equals multiply. Multiplied by 1. We need groups of 3. We have 6, so we can bring 2 groups to the outside, and 2 groups of x's as well. That gives us 2 over 4x squared. Reduce your fraction, and that's 1/2 with x squared on the bottom. 3 more problems and we're done with today's notes. We got the cube root of 125x to the 9th all over y squared. When I look inside, I don't see anything that can be reduced, so I'm going to break it apart into 2 pieces. 125 can be rewritten as 5 cubed, so I go ahead and do that, and the cube root of y squared. On top, I have enough to bring that 5 out. I needed 3, and I have exactly 3, which means there's no leftovers on the inside. 9 x's, that means I can bring 3 groups out to the outside. And then when we look here, we have to rationalize because we have a radical on the bottom. We need 3, we have 2, which means we need 1 more y. So that's being multiplied by the cube root of y on top. We've created that perfect cube root on the bottom so that y goes to the outside. And we look and there's nothing else that can be reduced. Remember, inside the radical, outside the radical does not reduce down. Number 8 and 9, we are adding, subtracting. So remember, if we're adding, subtracting, we need like radicals. Just like when we add, subtract, we need like terms. These radicals are not alike right now, so we want to simplify and see if we can make them alike. 27 can be broken down as 3 cubed. So we need groups of 3. We have exactly 1 group of 3. We have 7 x's, which means we can bring 2 groups to the outside, taking out 6, leaving us with 1 x on the inside. In our second piece, we had x. We need 3, we have 4. We can bring 1 more outside, leaving us with 1 x left over on the inside. So this is 3x squared cube root of x plus x times x is x squared cube root of x. Now that we've simplified, we have that like radical. So 3x squared plus x squared gives us 4x squared of the cube root of x. Alright, for number 9, I want you to press pause and try this one on your own. Alright, for number 9, you may have thought that you made a mistake if you got 0 as your answer, but you were not wrong. We break down the first one. 8 is 2 cubed. We need groups of 3. We already had that 3 on the outside. We're bringing out that group of 2's. Well, there's no numbers left on the inside. X to the 6, which means we have exactly 2 groups for the x's, so no x's left over on the inside. Y squared, we need 3. We only have 2, so we can't bring any y's out, so both y squared stays inside. And z to the 4th, we need 3, we have 4, which means we can bring 1 group out with 1 group left inside, or just one, not one group. And we're subtracting, we had that 2x, 3 cubed, which means we can bring a 3 to the outside. We have exactly 1 group of x's. We need 3, we have 2 y's, so both y's stay on the inside. Z to the 4th, we can bring 1 out, 1 left over on the inside. We multiply 3 times 2 to give us 6, x squared z on the outside, cube root of y squared z, minus 3 times 2 is 6, x times x is x squared, z, and then we see that we have like radicals. Cube root of y squared z, those are exactly the same, so we are subtracting their coefficients. 6x squared z minus 6x squared z, because this is x squared z and x squared z, those are like terms on the outside, just like we have like radicals that we're adding and subtracting. Well, 6 minus 6 is 0, and we are left with nothing. And that finishes our video for today.